actual class, let me introduce you with the subject computer architecture. Actually, this for this subject, to learn this subject, the prerequisite is you should have a knowledge of physics. So not a knowledge of physics, basically a digital electronics. So it is something which is an extension of digital electronics. And in digital electronics, what we covered the gates, the s- the combinational and logical combinational and sequential circuits sequential circuits. And we all we covered that in combinational. There are several components like gates, half adder, full adder. And basically the main difference between a combination and a sequential circuits lies that in combinational there is no memory, right? There is no storage. But in sequential circuit we covered flip-flops, we we covered registers, and which is a memory device itself. Flip flop is a one bit memory device, and register is a it is made up of flip flop only. And it has if we connected four flip flop together, then it will be 4-bit register or a 8-bit register in the same way. So the basic difference lies between the combination and the sequential circuit is that in combinational there is no memory element is present, whereas in sequential circuit there is a flip flop, a register, and there is a memory element. So register and counters are the one of the examples of sequential circuit. Now let us talk about the this subject basically. First of all, why the students are confused to pursue this subject. Because let me open the pdf. uh, yeah. So first of all, this is your book, Maurice Mano, which is very very much famous in this subject. And everybody use this subject, this topic, uh, this book, Computer System Architecture. Actually, Maurice Mano comes into two different of two different subjects. One is digital electronics, and another one is this computer system architecture. So very first thing is you must have to do you must have this book, Computer System Architecture. If you don't have, you just request me. I will send it to you through a mail. So this is a book that you have to use. So let me start with the first of all the index of this book. See, in this book, the very first chapter is digital logic circuit. This is basically the revision of whatsoever you did in the digital electronics. You have to the only the same thing is discussed here. So since you already pass out this subject, digital electronics, I don't think so you should have but still, if you have a little understanding of digital electronics, I'll advise you all to just go and do little bit revision through this. So this from this chapter, from the exam point of view, there is no question. No question will be asked to you from this chapter, because this chapter is basically includes the revision of digital electronics, that is logic gates, boolean algebra, and k-map specification, half adder, full adder, and the flip flops. And this is very crispy chapter. If you want to review, then it is okay, but from the exam point of view, I am sure no question will be asked to you from this particular chapter. So now let me move towards the second chapter. Okay, in the second chapter, the digital components. The This chapter is also it is just for revision. So your course is not started from here. But still, you should have to understand what are decoders, what are NAND gates, and how we can design a decoder through a NAND gates. Then what are multiplexer registers, shift registers, So this is again and again last topic 2.7 is a memory unit. So it is all all about the revision of your digital electronics. So I'll advise you to just go and read, take a quick read from this chapter, and this chapter is again not so much important for exam point of view. So let me quickly move towards the third one is again is not important because this is a data representation, number system, hexadecimal, how to convert the number octal to hexadecimal, or how to represent the numbers. So again, this is something which is the revision part. So here also they aware about you the binary codes, the gray codes, decimal codes, and error detection codes. So all these are basically the revision. So let me start your course. Basically, the course is of computer architecture. It started from right away from this chapter, register, transfer, and micro operation. Now, before starting this, let me quickly, describe you what is. Uh, Before starting this, let me quickly introduce you computer architecture. The name. Let me aware you all why it is called computer architecture. See, computer architecture is basically there are architecture means what? Architecture means how a computer is designed. So there are two kind of architecture. One is von Neumann and another one is Harvard. So in von Neumann architecture and in Harvard architecture, I'll advise you to just go and read the difference. It is very important. In one of it, the memory unit is in within the on a board, and in one there is the memory system is is not on the board. So this is the main difference between von Neumann and Harvard architecture. So you have to first of all cover this thing how these von Neumann and Harvard architectures are different from each other. And again, the very important thing is how computer is organized, how it works. Basically, how the data is transferred from the memory to the, like in our body, as the blood flows from from the different part of the body. In the same way, how the in the computer, how the signals are moved from the from one component to the another component, like whenever we are doing certain tasks on a computer. Let us suppose this is our computer, and computer understand only the binary language. It understand only the binary language. So how it communicates with in a CPU, if you saw if you discuss it in a broad concept, CPU is the central processing unit, and it consists of many parts. So how these parts are interrelated with each other, how they communicated with each other, this we have to learn in this chapter, in this subject, that is computer architecture. I hope you all understand. And so before begin this computer architecture, you all must have to understand that computer architecture deals with the architecture of a computer, means how the data is flow, how the how the control system and instruction system works together. So this is all about the computer architecture. Now let me start this chapter first, the fourth one. To begin with, let me start it. This is very important. And okay, very quickly I'll move towards the fourth chapter. This is the book only that you have to do for computer architecture, and this is enough for this subject. So this is the third one again, the number. Let me quickly move towards the fourth one. See, this is the fourth chapter, and in this chapter, all the all the points are in your course. All the points ranging from the RTL, the register transfer, bus and memory transfer, arithmetic operation, micro operation, logic micro operation, shift micro operation, and arithmetic logic shift. All these seven topics are in your course, and this is one of the very important chapter, and comprises of almost 40% of your course. So almost 40% of your course ask from this chapter only. So you have to thoroughly read this chapter. Let me start this. First of all, what is RTL? To RTL is a register transfer language. You know, registers are the memory devices. Register are the memory devices from which the data is transferred and data are stored. So but this is not happen like this, that I am showing here like a line and transferring the data from here to A to B. It is not like that. It is basically done with the help of certain small instruction. That instructions are what we call micro operations. So this is very important, and this definition will be asked to you, what is micro operation? So micro operation is a set of, here it is written, the operations executed on the data stored in the register are called micro-operation. So any kind of and if I ask you what kind of operations we can do on a register, data stored in a register. So it may be, we can move the data, we can add the data, we can subtract the data from each other. If there are two registers, we move the data, we add the data, we subtract the data, we delete the data. There are so many operations, and these operations are individually they are called micro operations. So the operation executed on the data stored in the registers are called micro operation. This is very important, and these are the some examples are given to you. The micro operations are shift, count, clear, load. So they basically, micro operations are used for to do certain tasks on a particular data. So this is very important. And if we go ahead and then what is RTL? What is this RTL? This is very important again, and this is a way how to read this book. The what is RTL? RTL is the register transfer language. Thus, it is a basically as I told you, there are certain instructions like move, like shift, like add, like subtract. But these are instructions, but we are not given these instructions to the computer system directly. There is a way to give this kind of instruction to the computer, and the symbolic notation used to describe the micro operation transfer among register is called register transfer language. See, this is called the register transfer language, RTL. So register transfer, although people sometimes misunderstood that, people sometimes misunderstood that the RTL is a kind of language. But no, RTL is not kind of language. It is just a symbolic notation. But we are called it language because it is a symbolic notation of mentioning some sort of operations. So sometimes students are confused why it is called language, since it is a symbolic notation of representing the micro operation. So that's why it is sometimes also called the register transfer language, because these particular symbolic notations are used for transferring data from inside the register. That's why it is called register transfer language. So you can understand from here also, the term register transfer implies the availability of hardware logic circuit that can perform stated microoperation and transfer the result of the operation to the same or another register. This is a very important question, and I am damn sure whosoever made the paper exams, you set your exam, will definitely ask you, or whenever you sit for an interview for any other company or for entrance exam, definitely you will get this question with you. What is registered transfer language? And I hope you all understand. That is, the register transfer language is a set of notation. It's a set of kind of notations. What kind of notation we will see in a subsequent section. So this is a symbolic notation of representing a micro operation. So this is what we call RTL. So let me move forward to quickly. Uh, yeah. Now, what is registers? What are registers, and then what are register transfer? These two are the separate things. Registers, to understand this, first of all you have to understand, in the computer there are several several kind of registers are present. not a single kind of register. And what are the various types of registers are present? Let me first of all go through that. Okay. Yeah. Okay. We will see it later on. Let us suppose. Let me go ahead with this. Registers, computer registers are designated by the capital letter. This is a one very important. This is a one very important. Term. You whenever you have to represent a computer, whenever you have to represent a computer register, it must be designated with a capital letter. Like if I am saying, so see, these are the computer registers. For example, the register that holds the address of the memory unit are called memory address register, and in short, it is written as MAR. MAR. So memory address register, and this is very important. It is mentioning here. Every register must be represented with the capital letter. Other designated registers are PC, that is program counter. Program counter is basically responsible for counting the lines, number of codes lines inside the particular program. So or particular instruction set. That is what we call program counter. So it always pointed towards the number of lines in a particular code. Similarly, there is one IR register, that is for instruction register. As the name suggested, this is a register which stores the instructions to be executed. Because it is not happen to the computer that you give instruction and it executed. Actually, there is a set of instructions we provided at in a one go to the computer, and these the instructions are stored somewhere in a sequence. That is what we call IR, the instruction register, where these instructions are stored in proper way. And R1 for the processor register, and basically R1 are the general purpose register. It is basically for use. It is also called the temporary register, which is used for to doing the calculation, for the temporary calculations. We will see it in a subsequent section. So now there is one diagram 4.1 which is very important. It is mentioned here. The 4.1, you have to this diagram is also asked in the exam. What are the block diagram of the resistor? The block diagram of resistor is number one. This is a simple resistor R1. We can represent it like R1, and showing individual bits, we can represent the resistor like this also by representing the number of bits. It is a 8-bit resistor because it starts from the 0 till the number 7. So 0, 1, 2, 3, 4, 5, 6, 7. It is a 8 in number. That's why it is. This is another way, or another way of presentation of the resistor. And the third way is the numbering of bits. You can show it like 0 to 15. Like in this way, if you want to write this register, you can write it like 0 to 7. In the same way, since if it is not advisable to write the number from 0 to 15 in the box, so this is another way of representing the register. And this is the fourth way of representing a register, where the program counter is of 16 bit. Program counter PC is of 16 bit. So we can split it from 0 to 7 and 8 to 15. So means we can split the PC into the two parts of 8 bit each. One is called PCL, and another is what we call PCH. And PCL is basically the lower register, and the PCH is the higher one. So if you want to read about the theory of this book, basically it is not the diagrams are not correlated with the text. That is why students lose their interest. You have to read it, the figure 4.1, and see figure 4.1 is given in the at the bottom. So this is a very important 4.1 figure. Maybe asked to you how what are the different ways of presenting a register. So this is again a very important. Now register transfer. See, information transfer from one register to the another is designated in symbolic form. That is what we call RTL. So whenever you want to write transfer, let us suppose you want to write transfer data from register 1 register 1 to register 2. So if you want to give this command to the computer, you need not to be write the full sentence. This can be represented by r2 and r1, means the data whatsoever the data in the r1, it can move towards r2. You can't write it like this r1 r2, right? This is the wrong way. This can be only written like this: the data of r1 is moved towards the r2. This is basically a convention. See, here it is written here, R1 does not change after the transfer. So it means whatsoever the data in R1 denotes a transfer of content of R1 into R2. It designates a replacement of the content of R2 by the content of R1. Whatsoever data earlier, if there is any data in R1, it is replicated by the data of R1. So by definition, the content of the source register R1 does not change. The data is remain same in R1 also. So sometime also, this will ask to you how this is represent how this represent R1 is transferred to R2. What it means? It means whatsoever the data in the R1, it gets transferred to the R2, but it doesn't mean the data of R2 transferred to the R1. And another important thing is the data of the R1 remains same. Whatsoever the data in the R1, it remains same. It does not change. So this is the meaning of this instruction. So let me quickly move towards next part, next topic. Yeah. Now this is sometimes we want to give a conditional transfer. Then if else statement can be used. If then statement, how it works: if p is equal to 1, p is it's a condition. It is a control statement, basically control condition. If p is equal to 1, then only the data of r1 excuse me, then only the data of r1 transfer to the r2, only when this particular control signal is executed. Whenever the country particular, if b, let us suppose the value of b is 0. Now what this indicates, for students, they assume that it is only the condition. When it is okay, then only the data is transferred. But if you understand, this is a kind of switch. It is a kind of switch. When you press that button, then only the data is transferred. Earlier, with this statement, what it means? This means the data of R1 is copied into R2, but there is no control. But if you want to put a control over here, then you have to write it like this: if p is equal to 1, then r2, then data of whatsoever the data of r1, it get transferred into r2. So in this is but this is again get shorted and written it like this: P. If you write P, it means it is, and colon, it means this is a conditional. So, and this condition means whenever the hardware only, when it get P is equal to 1, then only the data is transferred. This is completely understood. So, see, if yeah, this is a very important question. Sometimes what the question is coming in the exam to represent this with a circuit diagram. Draw the circuit of this. So see, the circuit of this is very simple. See, the data of r1, n is written here because it is an n bit. Sometimes the teachers are the question, they frame the question like that: you have to design it for 8 bit. So for 8 bit, you have to write it here 8. N is 8 here. Mind it, sometimes it is asked in the exam for 5 marks. And draw a block diagram for transferring 8-bit data from register R1 to the R2 when P is equal to 1. So P is equal to 1 is a control circuit. You have to connect the control circuit with this transferring, and this cut means the n is variable, means the n is not 1, it is variable here. And if the question asks to you, you have to transfer 8-bit data, then you have to choose n is equal to 8, and it means the 8-bit data now transfer from the register r1 to the r2. And clock, many of you may be asked and may be confused why clock is there. For this, I'll advise you to just go and learn digital electronics. And digital electronics, it is told to you that the registers, they are made up of flip flop, and in flip flop there are clock. So this is a clock, basically which is a common clock, maybe connected to the number of flip flops. So I am not, indulge myself now in digital electronics. If you have a doubt why clock is here, you just go and learn this of digital electronics. So let me quickly move towards the next. Yeah, this is a timing diagram that also required for an exam. So whenever the clock pulse is high, see, whenever you have a clock pulse high, then only the data is transferred. The data is transferred from here in between this. Now you may have confusion why not the data is also the clock is high here also. Why not the data is transferred? Because uh, and I'll request you all to search for this answer. Otherwise, I will tell this in the next class to you. Why not data transferring started here? Why it is started here? So this is the timing diagram, and I'll request you all to just go and search this answer. Otherwise, I will tell you in the next class about this. So let me move quickly. Although the answer is specific, is already specified here, I'll just give you a hint. You just go and read this. Now, very important question. Very 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 important question. This table is very important. Basic symbols of RTL. It is asked in the exam, and how the notation of the different register like MAR and R2. These are the letters. Donates a symbol. Parenthesis. This is very important. Denotes the part of the register. Whatsoever you write in the bracket, it denotes the parts of the register. If I write it 0 to 7, it means the register R2 consists of 0 to 7 bits, and R2. If I write L, it means it is a lower register. Arrow denotes the transfer of the information. If I write it R1 arrow R2, it means the data of R1 is transferred to the R2. And comma basically separates the two micro operation. These are the certain rules. So basic symbol and certain rules that you all must have to learn. So now this is a very important circuit, and definitely this will be asked to you in the exam. But today we covered till this point. Since the and definitely we will cover this the whole topic tomorrow from the full chapter. I'll finish the full chapter tomorrow. Why I am not covering it today? Just because I just give you a time to just to start this computer architecture. So I request you all who whosoever watching me to just read the just give a quick read up to this table 4.1, and let me quickly recap what what we covered today. We covered what we covered today. We covered RTL, register transfer language. We covered micro operation. We covered how the registers notations can be represented. What are the different kinds of register? We cover all these concepts today, and we will meet soon tomorrow at the same time 10 o'clock, and we'll cover the whole chapter tomorrow. Till I will request you all to you just go and read the chapters, the previous chapters also, so that there is a quick revision of your digital electronics, and then we will finish this chapter tomorrow. And this is I already told, this is a very important chapter, almost compromise 40% of your syllabus. So with this, I am ending this class here, and we'll meet you soon tomorrow, same time. Till then, stay tuned. Bye bye. Thank you.